Welcome back to our SMS Foundation. This is question 1B. We want to be solving question 1B now. The question 1B is on calculus because the question is asking us to calculate the volume of a solid generated in terms of pi when the curve y equal to root x between the limits x equal to 0 and x equal to 2 is rotated completely around the x-axis. Now, this question, the best way to solve this kind of question is to use calculus. And calculus is even the method required here because this is an application of integral calculus. So, let's go. I come with solution. Now, over here, the first thing to do is to write out my given curve. I have y equal to square root of x. And then the limits given. What are the limits given? Limits given are x equal to 0 and x equal to 2. First of all, when they say calculate the volume of a solid generated, if we represent this curve, we don't even need to represent it, but I just want to show you how the diagram would look like if we are to represent it. This is how the diagram will look like when we have something like this. So, by the time this is the x-axis, positive x-axis, and this is positive y-axis. By the time this is the 0 part, and then this is 2 on the x-axis. By the time we rotate this, it's going to give us something like this. By the time we rotate this, about the x-axis, it's going to give us something like this. So, this is what they are talking about. See? This is showing something like a solid. It's giving us something like a solid. That's the meaning of the volume of solid generated. So I just use this to explain how the diagram is going to look like. So if this is called y equal to square root of x. Now, if we continue, the diagram is not necessary. The diagram is not necessary at all. I just want to show you how the picture will look like. Now, this is the formula. We have the formula, a standard formula for that. Our formula for finding the volume of the solid generated is given as volume V equal to square root of pi, volume V equal to integral from A to B of pi y dx. Note this formula. This formula is used whenever the curve is rotated about the x-axis. If it is rotated about the x-axis, this is the formula that we are using. About the x-axis, rotation about the x-axis. Rotation about x-axis. Now, the formula to use if it is rotation about y-axis, we can use this. Oh, excuse me, this is going to have square. So pi y squared dx. And then this will be pi x squared dy. This is rotation about y